Hello viewers, today we are going to start with the chapter current electricity from class 10, and this chapter is there in both CBSE and ICSE, so this video would be useful to both boards. Okay, so before starting with current electricity, let us know that what are charges and where do we have read this word charge. So you must have read it beforehand that when we rub any of the things together, the friction give rise to static charges. Static charges is something that remains on the body, and as soon as you touch them, they just vanish away. Like especially during winter time, when you touch something, like you touch somebody, Hana, you say, "Arey, I felt a shock," or you're giving electricity, something like that. You must have done it. So that is all static charges, and charges are nothing but the property of the subatomic particle. What is subatomic particle? Electron, proton, neutron we don't take here, we usually take electron or proton, so which give rise to some force. So you don't have to do the definition, it's just like I'm telling you about what are charges, right? Now the symbol for this is given by Q, and SI unit is coulomb, right? And there are many units along with that given, that is the smaller unit and the bigger units for charge. So this you have to remember: milli, micro and nano. So you should know how to remove this milli sign. You have to replace m by 10 to the power minus 3. If you want to replace micro, so you need to replace 10 to the power minus 6, and nano means 10 to the power minus 9. And when we say static charges, these are usually the charges that come when bodies are rubbed together. So that is due to friction. Like suppose if you rub the ebonite rod with fur, so ebonite acquires negative charge and fur acquires positive. And similarly, I've done it with this also. When you rub glass rod with silk, so glass rod acquires positive charge and silk cloth acquires negative. So that is all static, right? Of course this is not going to come in your exam, but you should have information. The main chapter actually starts from here, that is the concept of current, right? Concept of current. So what is basically current? When we say charges that are in motion, we say it is current. So remember, when you consider charges that are moving charges, moving charges could be electrons or proton. Basically we usually take electrons in motion, protons being inside the nucleus are not considered to be in motion. So remember, electrons in motion is said to be current, and the formula for this is I is equal to Q by T. Q is the charge. In some books Q is charge is written by this symbol, and sometimes it is written by this, so accordingly you can use the sign whatever is given in your book. I is equal to Q by 2. Q is the charge and T is the time. Unit would be, unit of Q is C and of time is second. So coulomb per second is the SI unit of current, and this I is replaced by this coulomb per second is also said to be ampere. And now if suppose they tell you that in case you have say n number of electrons which are moving, so I formula will become charge would be replaced by how many electrons you have and into charge of one electron divided by time. And how this this current is measured with the help of a device called ammeter. You must have seen it in your ACs where you use a stabilizer. So there is a device where it is written capital A, and one more device is there, capital V. So capital A device is actually your ammeter. And now this you have to remember, the electrons flow from negative terminal to positive terminal. This you already know, because electrons will be attracted towards the positively charged, of course because of the different nature. But when we say conventional current is a current direction that we are going to use in whole of this chapter. So conventional current direction is taken from positive to negative. So if you just give a look, positive to negative, so it is actually the direction opposite to that of electron themselves move from negative to positive. Conventional current direction is taken from positive to negative, which is actually the direction of proton.